So here now we want to talk about some of the basic definitions that are involved in statistics. First of all, we have experimental units here, which are the object or person, event, transaction, whatever thing you're collecting data on. And then the population is the entire set of units that are of interest to you. The sample here is a subset of the population. And it could be representative or non-representative. And then when you talk about a statistic, that's some numerical value that's summarizing the sample data. So statistic and sample both start with S. So statistics refer to sample data. So like the mean height of the people that are in your sample, for example. And then parameters are numerical values that summarize the data in the population. And notice both of those begin with P. So parameters refer to the population. Our variable here is going to be our characteristic of the population unit. So whatever characteristic that we're interested in. If we're talking about people, it could be their height, their weight, their blood pressure, etc. And then the statistical inference is the prediction. The conclusion or generalization that you're going to make, and it's about the population, but it's based on the sample data. So you're generalizing from sample to population. And then statistics will always include some reliability measure, which is some quantified statement here. So you've got a quantified statement about uncertainty in your inference, because you're never 100% sure of your inference. So let's look at an example here. So we have a medical device maker who wants to test the reliability of a new mechanical heart valve. They randomly select 50 valves and test them to see how many cycles they take to fail. Mean failure rate of the sample is 12.5 million cycles, and they predict the manufactured valves will last 12.5 plus or minus 1.2 million cycles. So this sample is the group, the smaller group that you collect information on. That's going to be the 50 valves here. So the sample is the 50 valves, and you can't just tell me 50. 50 what? 50 people, 50 bicycles, 50 heart valves here. And then the population here is going to be all valves, heart valves here, but it's not all heart valves made anywhere. It's just going to be for that manufacturer for that location. So let's say all valves at that location. A statistic, so some numerical measure that refers to the sample here. So let's see here, the mean failure rate of the sample, so of the sample, so referring to the sample, is 12.5 million cycles. So that would be a statistic. It's a characteristic, a numerical quantification of the characteristic of failure rate. So 12.5 million cycles is a statistic. And parameter, we don't have a specific parameter that's listed here, but the parameter we're interested in is the failure rate. And by rate here, I mean the number of cycles per failure of the population of heart valves. The variable of interest here is how many cycles to fail, which we're calling the failure rate. So the variable here is cycles to fail. And by cycle, it's an opening and closing of the valve here. Does this study involve descriptive or inferential statistics here? Well, keyword here, they predict that the manufactured valves will last this long. So predict, that's going to be inferential. What inference could they make? Well, here's the inference right here. So the prediction is that the population valves on average are going to last 12.5 plus or minus 1.2 million cycles. So the inference is that the population failure number of cycles is 12.5 million. And we could attach, now the reliability measure is going to be the plus or minus 1.2 million cycles. So plus or minus 1.2 million, that tells us how reliable our estimate is, how reliable the 12.5 million is. But we need a probability, so a reliability that's attached to this 1.2 million. So we need also here, we need the probability of that happening. So we need some numerical measure that's of how likely that is. Is this sample likely to be representative? Is it going to have the same characteristics as the population? Well, these were randomly selected valves, so the answer is probably yes. Random samples generally are pretty representative, and unless there's some other bias in the experiment. So yes, because we had a random sample.